Okay, video A7. We're still studying the beginnings of logarithms, and we have one giant question today. I think this is question 3. I want you to find the inverse function. I want you to graph both functions. And then I want you to analyze the inverse. All right, so big problem. Okay, the function we're going to start with, I'm going to write it using y instead of f of x. Y equals 2 to the x, clearly an exponential function. In our last set of lessons, we analyzed and graphed that. Okay, but let's go ahead and start. Let's find the inverse first. So here's how we find the inverse, just like we've done. Okay, the first thing we do is we switch x and y. So x equals 2 to the y power now. Okay, so clearly I need some method of solving for y. Well, it's going to be a logarithm. So I'll circle the base, go across, and come back, and I'll get log base 2 of x is y. So I'm going to write it backwards. Y equals log base 2 of x. So here I have my original function. Here I have its inverse. Okay, just as an aside, what do you think you would get if you were to make a composition of these two functions? So remember, when you compose inverse functions, you should just get x because one will undo what the other did. Okay, so we found the inverse. Now we have to somehow graph both of these. Okay, and so let's take it slowly since we only have one problem today. Okay, I think I know how to graph this one. What we did before, I'll write it down here, y equals 2 to the x. I made a table. I'm going to make this really quickly. Okay, and so I used 0, 1, and 2, and negative 1 and negative 2 for x. So here I have 2 to the 0. 2 to the 0 is 1. 2 to the first, 2 squared. So I'm doubling this way. Remember how we're halving this way? So I have that. I'll box this up. We'll plot those so we get a relatively neat graph. But now we've never graphed a logarithm before. So since it's an unknown function, I'll write it right here. Let's actually take some time and make our table of values. And what I find is that most students on these like to choose the y values and then figure out what x is, like this. I'm going to choose y equals 0. So now I'm saying 2 to the 0 is what? Well, clearly 1. Okay, I'll choose 1. 2 to the first is 2. Then I'll choose 2. 2 squared, remember we're choosing the y. 2 squared is 4. Then I'll see if maybe I can choose negatives. So negative 1. 2 to the negative first is a half. And then negative 2, 2 to the negative second. Remember that's 1 over 2 squared, so 1/4. And then we realize we did a bunch of work we didn't need to do. Because the first thing we learned about inverses is all we need to do is switch the x and the y. And look, every single ordered pair, we've switched the x and the y. So now for graphing. I just need to go up and out 4 each way. I'll go ahead and graph y equals 2 to the x for something we've done before. So once again, I'll do it quickly. 0, 1, 1, 2, 2, 4, negative 1, 1/2, and negative 2, 1/4. And we get an exponential growth curve. Growth because b is bigger than 1. Okay, so then if I plot these points, so the inverses of all of those points, 4, 2, 2, 1, so 2, 1, 1, 0, 1/2, -1, and 1/4, -2. So we see our first logarithmic graph. I'll go ahead and label these. This is y equals log base 2 of x. This is y equals 2 to the x. They better look like they're reflections across this line, and remember what the equation is. Reflections across the line y equals x. So you can see they are. Each point has a reflection. And now to analyze it. Okay, so let's start with the domain. We're analyzing y equals log base 2 of x. So our domain, well, let's look. It looks like we have something going on here. Remember how with a logarithm, okay, the x value can never be, this value right here, can never be 0 or negative. Okay, and so it looks like I might have an asymptote. We'll include that in the analysis in a bit. Okay, so my domain doesn't include 0, but it goes to the right forever. My range, well, the y value can be anything. It goes up and down forever. We were just choosing whatever we wanted. Okay, and then what we want next, do we have any x-intercepts? We clearly do right there. There's our x-intercept. So the ordered pair, remember these have to be ordered pairs. Do we have any y-intercepts? Okay, so since we never cross the y-axis, clearly we have none. Is it ever increasing? Well, notice as I draw it to the right, it's always going up. So for the entire domain, it's increasing, which means that it's never decreasing. How about end behavior? Okay, as x goes to the right, what's going on? Well, it looks like it's getting kind of shallow here, but it does go up forever, so y goes off to infinity. And as x doesn't go to the left, but x is approaching 0 from the right, and we write that like this. We're approaching 0 from the positive side, and the y values are going way down. Okay, and then the last thing I should include, are there any asymptotes? And there is one. It's the y-axis. Write it as the equation of a line, x equals 0. And so your homework that I want you to try, I want you to do exactly the same thing with a slightly different problem. So go ahead and pause the video. I'm about to flip this over and show you the worked out solution.